Hello friends, today we are going to see the numerical integration topic. Okay, so in that first of all we will start with the operators. So in the numerical integration, what is the operator? Operators, we have first one forward operator. Forward operator, this is denoted by the letter this, and then we have the backward operator. And that is denoted by the letter this. Okay, so here we have forward and backward operator. And the function f of x, we are denoted by the y is equals to f of x. Here x naught, x1, x2 and so on the xn. This is called the nodes, that is the point, okay, at which we want the integration. And if you substitute x naught in the function f of x, so that will give you y naught. So f of x naught is same as your y naught. F of x1, we will denote it by y1. F of x2, we will denote it by y2. And so on. F of xn, we will denote it as yn. Okay. So for corresponding value of x naught, we will get y naught, y1, y2 and so on. So this is the functional value at a given nodes x1, x2, xn. Now what is a forward operator? Delta. So if I want to calculate delta of f of x, okay. Now one more thing, if I want to find out x1, so how to find out the x1? For the uniform step size, we can calculate x1 by adding some specific quantity, that is step size h to x naught. And similarly, if I want to find out x2, so I can add h to x1. To find out x3, I will add the h to x2. Okay, and so on. Now if you substitute x1 value here, that is x naught plus h, so we will get, if I substitute x2, what we have in the x1 we have x naught plus h, and this plus h will here, so we will get x naught plus 2 times of h. Similarly, if I substitute x2 value here, so I will get x3 is equal to x naught plus 3h. Okay, so in general, if I want to find out xn, so xn is equal to what? X naught plus n time h. In this way, we are finding the next value. Now, come back to the forward operator. So what is the forward operator? In the forward operator, what we have to go one step ahead, that is f of x plus h minus the current step, which is f of x. So this is a forward operator. For next value minus the current value, that will give you the forward operator. Now backward, in the backward operator, what we are doing, the current value minus the previous value. So how we will get the previous value? F of x minus h. This will give you the previous value. So this is in terms of f of x. Now if I want to find out in terms of yns, okay, so forward operator of y naught, this will give you the next value. What is our next value? Y naught के बाद क्या आ रहा है? y1. So what we have? y1, that is the next value minus the current value, which is y naught. if I want to find out backward operator of y naught, so backward operator of y naught will give you the current value, that is y naught minus the previous value, which is y minus 1. Similarly, if I want to find out delta of y1 in the forward operator, so this will give you the next value, which is y2 minus the current value y1. Backward operator of y1 will give you y1 minus the previous value y0. The next, if I want to find out delta of y2, so this will be y3 minus y2. Backward operator of y2 will give you y2 minus y1, the previous value y1. Okay, so in this way we can calculate the forward operator and backward operator. Okay. Now the next thing, we will solve one example so that you can understand easily how to find out the backward operator, how to evaluate the backward operator and forward operator. So for example, if I want to find out delta of e to the power ax, okay, delta of e to the power ax. So here we have the forward operator and we will take the step size as a h. So to find out this, what should be the next value? So this is the forward operator. So next value of e to the power a, in x we will add x plus h, because we have delta of f of x is what? F of x plus h minus f of x minus e to the power the a power x. Now if you simplify, we will get e to the power ax plus ah in the power only, e to the power ax. Now base is same, we can separate the base, e to the power ax into e to the power ah minus e to the power ax. Now e to the power x is common, so we will take the common, e to the power x is common. What is left? E to the power h minus 1. Now if in the question they have asked for specific h, so we can substitute the h value here, otherwise we will keep as it is. Okay, so somewhere they are asking for h is equal to 1, so put h is equal to 1. So what we have, delta of e to the power ax is equal to e to the power ax, e to the power a minus 1, because we are substituting h as a 1. So this is our final answer for this. Now we will solve one more question. That is delta square of e to the power x. How to calculate delta square of e to the power x? So this will give you delta square, we can write down delta of delta e to the power x. Now operate this forward operator to e to the power x first. So this will give you e to the power h, x plus h minus the current value e to the power x. Now open the bracket, so this will have delta of e power x plus h minus delta of e to the power x. Now if we simply again operate the delta value here and delta for this one, so here we have x plus h. Again, if we are using forward operator formula, so delta of f of x will give you delta of x plus h minus f of x. So this become e to the power x plus h minus e to the power x plus h, because this is the current value, minus, in this one we will get e to the power x plus h minus e to the power x. Now if you open the bracket, what we have, e to the power x plus 2h minus 2 times of e to the power x plus h, and this minus minus become plus, this minus will go inside, that become e to the power x. Now for specifically h is equal to 1, what we have, e to the power x plus 2 minus 2e to the power x plus 1 plus e to the power x for h is equal to 1. Now if you take e to the power x common, so we will get e to square minus 2e plus 1. E square minus 2e plus 1 can be written as e minus 1 the whole square. I hope it is clear to everyone. Thank you for this lecture.